Hi, this is number 34 on page 186. It's the Tarzan problem. And it tells us that Tarzan, it doesn't tell us his mass. He starts up here where theta is 37 degrees. The length of his vine is 30 meters, and he's going to swing down. We want to know at the bottom down here, when he reaches the bottom, right here, what's his velocity? That's what the question wants to know. Well, to do that, we're going to use energy, and we're going to find what is the initial energy of Tarzan. And they give us two situations. Point A has him starting from zero. Point B has him starting with an initial velocity of 4 meters per second. And then we're going to find what the number for the final velocity is, which will be the same. So in both situations, the initial energy is potential gravitation, which is mgh. Now, I don't know if you noticed, they didn't give us mass, so we cannot get a number here. We could say 10 times whatever h is, but we can't get a number right now. But we do need to find h, and so let me show you how to find h if you have a problem like this. It could be a pendulum or a swing problem. They're all done similar. If you just go across here, yeah, I don't like that. Hold on a minute. All right, so if I just go across here in sort of a straight line, this is where Tarzan is, how high he is in relation to where he will be. This distance here is our h. So how do I find that? Well, we can use a trig function to find this distance here. And since we know this is 30 and we know the hypotenuse, I'm sorry, this is 37 degrees and the hypotenuse is 30 meters, this is the adjacent side, so I could use cosine to find that. Cosine of 37 degrees equals opposite, which I don't know. We'll just call it y. And so we'll call this y. And that's over the hypotenuse, which is 30 meters. So if we just take 30 meters times cosine of 37, we'll get, and y basically, when we round off, I think you get 23.959. So that basically, y basically equals 24 meters. Well, to get h, we're going to take, because when Tarzan gets down here, this whole length, y plus h, is going to be 30. That's not going to change. And so the h that we're looking for is going to equal 30 meters minus 24 meters, which is obviously 6 meters. So h is going to be 6 meters. So what kind of energy does Tarzan have down here? And that's Ke. And we know Ke equals 1/2 mv squared. So if we want to know the velocity of Tarzan, we do Ei equals Ef. Normally, if we had mass, we could get a number, and that number would be the same before and after. But in this case, we don't have a number. So we're going to write down PEG, which is mgh. That's his initial energy, whatever number that is. And that's going to be the same number he has at the end, which is 1/2 mv squared. Notice my m's divide out. V is equal the square root of 2gh, which is going to equal the square root of 2 times 10 meters per second squared times h was 6 meters. So that's going to be 120 square root, right? Second square root of 2 times 10 times 6, and I get 10.95, which is basically 11. So his velocity in A is basically 11 meters per second. Now, this is the A part. The B part, my initial energy is PEG plus some KE, both. And so this is K initial, all right? So I have some potential gravitational, and because he's moving, I have some initial kinetic. I have both on the second part. Well, what that does is that tells me that EI still equals EF, same thing. This is going to be mgh plus 1/2 mv initial squared has to equal, all he has at the bottom is kinetic 1/2 mv final squared. This really was final here, but since we only had one, I didn't have to do that. Again, my m's divide out, and we're going to have 60 here plus, what is this, 4 squared? It's going to be 8 here. So I have 68 equals, oh, this m divides out, 2 equals 1/2 VF squared. So 68 times 2 is 136. So it's going to be the square root of 136. And that's going to equal 11.66, or basically 12. And that's for the B part right here. So this is the B part all down in here. There's the B. There's the A. Meters per second. And that's how you do that problem.